the SaaS architecture, and there's never right or wrong. It's always, has to be right for your business, right for your customers, right for your technology. There is just a difference on how optimized it is. So one thing, to me at least, important to say, there is never right or wrong. It has to match your business needs. So there are more exotic ways, less. So really important, always remember that it has to match your business needs and not only what looks really sexy. So today I want to talk about two separate domains when building SaaS. So there are two main areas that you should be kind of looking at when you build your SaaS. The one is your application, either it's a new software or whether it's an existing software and existing intellectual properties. This is one problem to solve and to find the right architecture for it. And the other domain is the whole SaaS control plane, is everything which the shared services to manage and operate the SaaS. One thing that I keep on mentioning to our customers is always keep in mind that those shared services, this control plane, should be treated, to my opinion, as a product, the very same thing as you treat your actual application. And because there's a lot of features, a lot of capabilities, so what I'm recommending is treat it like another product on your journey to build your SaaS. So when we talk about the domain, so one is again your application. The other is the shared services, which is including the onboarding component, meaning how you create an environment. The tenant management is how you orchestrate this. Billing really critical. You do want to charge. You do want to understand your cost per tenant. You do want to be able to kind of provide different tiering capabilities. You want to manage the users, the identities. You do want to provide some analytics to understand the usage. And of course, the whole management, monitoring, observability that comes behind it. So whenever we approach building a SaaS, this is how we look at that. How we look at that, from a product standpoint. One thing general, by the way, guys, if you have questions, I don't see the chat. Feel free to kind of open your audio and ask, as it's going to be hard to me to kind of see your chat. And I welcome you to kind of question in between. No problem for me.
I think we will have some time at the end, Lahav, because I started the recording, so this will be recorded, and then when we open it for discussion and Q&A, we'll stop the recording and then start that. All right.
Right. So, I mean, key architecture points to be aware of is when we build the SaaS. Is first a noisy neighbor. When we talk about noisy neighbor, it's not about just exhausting compute. It is about consuming a lot of resources that might affect other customers. It could be touching the Amazon limitations. It could be exhausting, pools. So when we talk about, building a multi-tenant SaaS, we want to make sure that every customer really feels that we provide only to this customer the service and is never being impacted by other customers. The other key aspect is how we create the isolation in between tenants. We never want data or users to be able to access cross tenants. We never want users to be able to see the other tenant data, even if it's intentional or unintentional. We want to create very strong isolation in between the tenants. We always want to see the ability to provide some tiering. There is never one size fits all, and we are always seeing the need to provide the tiering. So we do want to be able to provide this kind of granularity mechanism or providing different kind of tiering of our product. We do want to hide the whole multi-tenancy information, whether it's the tenant ID, all those identifiers that we use internally to distinguish between tenants. That's something key when we build the architecture. We should think how we route the users or the agents or the devices into the tenant. And I think this is really key, is the frictionless onboarding. We want as quickly as possible to have the initial setup running and have the user connecting without any unnecessary setup, with as minimal as possible configurations. So always think of what will be the user experience when you register, when you create the tenant, how quick and how easy will it be for the first steps for the users to go in. I do want to talk about the different patterns, and I will start with silo. Silo meaning really building silos of resources which are dedicated for a customer. The first option of building this silo approach is really, a complete separation in between tenants and having each one of them in their own AWS account. It is the most heavy, relatively approach to do. However, it provides the best isolation in that sense. And the reason to go with this approach is, I think very often, maybe the complexity of the system, maybe some necessity for private networking with your customers, regulation requirements, security, or maybe your solution is hard to provide the multi-tenant, and you still need to have this kind of very strong separation in between the tenants, and you may decide to do it per account per tenant. It looks the less sexy approach, but if it's necessary, it's necessary. Don't fight it too hard. It's legit. I said at the beginning, there's no right or wrong. The other typical situation that we are seeing in the silo approach is having, the VPC per tenant. That means that, the multiple tenants will live in the same AWS account. However, they will be living in separate VPCs. This is a very typical situation when you have to do private networking with your customer, and the network isolation provided by NACL, by security groups, by other techniques, by namespaces, it is not sufficient, and you do need to create this a strong network isolation in between them. This is a classic situation to use. The overall overhead of having a separate VPC per tenant is not so big, so the cost overhead behind it is really limited. So, comparing to an account per tenant, which is a few more services that are required to be enabled per tenant. So in this option, it's going to be more cost effective, and it's relatively easy to maintain in that sense. The other option, talking about the silo approach, is having multiple tenants living in the same VPC. However, they are living in separate subnets. That's an option. I think it's more complex to manage than living in the same VPC. Than having separate VPCs. Just imagine you do have to slice your VPC to so many subnets, and it's hard. And maybe there's 5, 10 tenants, it's fine. But when you have to go to 100 or more than that, these VPCs become really congested, and it's really, really hard. But what I'm trying to say here, all three options are completely valid and are really subject to what you need with your application. We did talk about, the silos, but then we talk about the control plane. We talk about the shared services. Here, we definitely suggest to have these shared services and control plane are really multi-tenant to set up everything. So The control plane, I think normally from what I'm seeing is one for your SaaS, maybe one for your region, but definitely something that is used across tenants. So it's the onboarding component, the whole management, deployment, identity is part of the control plane. Definitely metering and billing and logging is something you do want to create and make a multi-tenant from the beginning. Otherwise, it's really, really hard, I think, to maintain it and have this kind of seamless experience operating it. So when we're talking about the multi-tenant, I think the first question to ask is how do we route the traffic into the different tenants? A typical approach that we see and we definitely suggest is to have to give every tenant their own domain name. And the reason for providing this domain name per tenant is very often enterprise software requires some whitelisting on the customer side. And when you have a dedicated name per tenant, it's easy for the security team at your customer side to whitelist the access into your tenant. Otherwise, there'll be different questions whether my users could access additional resources beyond my tenant. So definitely having a name per tenant is easy way to solve it. We can start by having different names with a DNS pointing to different VPCs with a different load balancers. The advantage of this kind of setup is that tenant context is set very often through environment variables. It's easy to configure in that sense. They could be identical. It's very scalable. It's a typical situation we see for large setups. You'll see later on how we do lots more sharing, but still, if you need a silo, this is a very clean way to do it. Let's go deeper into routing the users or the devices or whoever wants to consume the service. A very typical way, I said, is doing a domain-driven routing. And this tenant routing very, easily can be set through like an ALB or a shared network device that is routing the traffic into the tenants. So this name-based could be, I said, ALB, let's say a single ALB pointing into two separate silo deployments. It's clean. One customer won't be able to notice another one. We can very often use some wildcards here to do the onboarding even quicker. That's a very simple approach that very often do not require any software changes in order to achieve it. The other option to drive the users or the connectivity into the tenant is within the context inside the request based on the JWT token. So the users will authenticate somewhere, will hit the API, and based on the JWT token, this software layer will identify the user tenant context and route it down into the tenant. Another aspect now we're going to, so we did talk about routing the traffic across tenants, but I said, there's a whole control plane behind it. And in this kind of situation where we have multiple tenants, each of them living, let's say, in their own VPC, okay, they're very siloed. We do want to provide the control plane as a multi-tenant solution. Very often, this solution has its own web API, web UI, and in order to expose these capabilities into the tenants, it could be metering, could be logging, could be other services that we do want to provide into the tenants. The nice way to do that is using, could be private links. If you're familiar with that, is the ability to punch a hole in between VPCs with a complete topology hiding complete possibility for IP overlapping. So the idea is to create, this interaction between the shared services control plane into the tenants in a very lean way. So I did touch on, how we integrate the management services into the tenants. So here are a few possible ways. I did touch on the private link, which I think is a very clean way to do it, and very secure in that sense. I still create a very strong decoupling in between the environments. Another option is to do it, yes, by VPC peering. However, this option definitely is harder to achieve because we are creating a complete route in between the VPCs, the two services. I think it's harder from a security standpoint. It's harder because you cannot do IP overlapping. I think it's the less preferred, but in some cases it is required. And definitely the cleanest way to do that is based on messages, leveraging event bridge, and eventually, pass control messages from one side to the other. This is the cleanest approach to provide this integration between your management stack and the environments themselves. Here is the flow of provisioning a new tenant. So imagine that the users signed up, or the admin decided to create another tenant, and we are starting the onboarding flow. Then we start to provision the resources into the environment. We create the tenant infrastructure. And again, we said we want it to be as simple as possible, as smooth as possible. So this is how we do that now. As we said, there could be creating an account with the resources inside, creating just a VPC, or just some resources. But look at that, whatever the model that you're using. Just imagine that the provisioning flow has to be very, very clean. So you do the provisioning side, and then the infrastructure, and then bring the user into this environment. There is very frequent a confusion, or a disagreement, or a discussion between whether a managed environment is a SaaS and versus a managed deployment versus SaaS. The key differentiator, as we see it, between what's a managed environment versus a SaaS, I think it's mostly around the how many versions of the software you run. And having multiple versions of software running in the same environment requires multiple pipelines, very often required a separate pipeline per tenant. I think it's good, but at low scale. It's really, really hard to build a large-scale deployment using this way. It could be a very good starting point, but once you get at scale, this is hard. So manage is fine, but it's I think it's less recommended if you can avoid it. The classic SaaS is, as we identified, there is one software version running, serving multiple customers. It does not necessarily mean they're sharing the resources. They can still be very siloed. And the whole control plane solution is something we share. We build the whole product for the control plane, for the shared services, which is serving all the tenants. I think this is a big difference between the managed and the true SaaS. And again, when you think, as this discussion is talk about, your migration strategy or SaaS pattern, I would encourage you to look more into the SaaS approach, with a control plane as a product that you have to build to support your environment, and try to avoid the managed situation. So now we touched on the different approaches. I want to show you now an example of an architecture. that is leveraging EKS as a Kubernetes cluster to deliver your SaaS application. So conceptually, what does this stack normally look like? So starting from the right, we do have the control plane, web console, web UI, and this is used by the SaaS provider. A typical situation. Then you have your SaaS application, which is could be siloed, could be shared, different options, and used by the tenants. And the whole landing page and sign up area where customers are signing up and launching the tenant. Behind this kind of user experience, what are we normally setting up? So the first thing to set up is the shared services, the control plane, the registration services, user management, tenant management, different capabilities. And aside to that, the different services that required for the SaaS, for the application itself, that is being used by the end customer. This is a kind of a very typical high-level architecture of what a SaaS could be looking like. So normally the way it's built is, and let's assume that in this situation we are in a mode that we are sharing resources. We'll talk about a Kubernetes. So the typical situation is that we share the Kubernetes cluster between tenants. We don't think there's a necessity for having a dedicated cluster per tenant. However, again, we try to achieve it. It's not always possible for different compliance and deployment reasons. If we do separate VPC, of course, and separate account, we cannot share the EKS cluster. And so the typical situation when you do shared services in this environment on EKS is definitely deploying the shared services on the cluster in their own namespace, starting to kind of isolate between whatever application, whatever tenant workloads and the shared services. And the important thing is, remember, on high availability and scalability. So we will deploy those shared services, registration, user management, tenant management across the cluster. And in order to provide the scalability, but also the high availability of our intended solution. Those services normally using a backend, either it's a Cognito user pool to authenticate the users, to provision Cognito's resources, and this whole shared service is meant to serve multiple tenants. So now the next step is, okay, how will the tenant application look like on this cluster? So it could be the same cluster, living in the same VPC, of course, across multiple availability zone. However, the out-of-the-box recommendation is to create a namespace per tenant. And as you can see, in order to achieve proper high availability, we are deploying the services across the EKS cluster, across the multiple availability zone. So each tenant gets their own namespace. This is a starting point for the isolation. There are more capabilities to implement in order for the isolation. It could also be the network policies and some other IAM related that we'll see in a couple of minutes. But a very, very typical situation we see when using EKS is a separate namespace with network policies isolating between the namespace, separate IAM roles per tenant, and setting the right limitations and the right capacity settings per namespace. So when we set up the namespace, so as you see, we wanted to route the traffic based, as we see before, based on names into the separate namespace. A typical way to achieve it is with an Nginx ingress controller. However, the recent load balancer controller, AWS load balancer controller, comes with the as an option to EKS, does a very similar functionality of routing based on names. The quick start, I think, currently having the Nginx controller as a routing, but this can be also replaced with the AWS load balancer controller comes, with EKS. And the main idea is that here we drive everything from code pipeline, the whole automation. As you will also see, I'll touch on it later. There's a whole quick start building what I'm showing here, and there's a code build that build this kind of tenants and set up the whole environment as we see here. So the flow normally works is, so the user or the admin register a new tenant. It will trigger a code pipeline that will build this build spec and eventually running, a kubectl commands, which will create, that the resources for the tenant, let's say the namespace, the right IAM roles, in order to consume some services, additional AWS services. It could be Dynamo, could be S3, very frequently attaching a KMS key per tenant, because you do want to encrypt each tenant with their own key, creating the Kubernetes namespace, attaching these IAM roles into the namespace, and deploying the set of containers of the application for the tenant. And then eventually it will do the ingress provisioning, the right scaling parameters, and deploy the tenant into the cluster. So again, based on the needs of your application, your security considerations, your compliance, there are cases where we do see a need for a dedicated cluster per tenant. And a typical situation that could result it is that your cluster needs to be really big. I don't think we want to go in a multi-tenant situation to huge clusters. This is where we start thinking about cells, is eventually a combination of multiple tenants into cell. And let's say every 50 tenants is a cell, and every time we pass the 50 tenants, we have to create a new cell. We always want to think about, limiting the blast radius. So again, a situation for this, that we do want to create this isolation in between and the separation between, could be even resulting in a separate EKS cluster per tenant. It's heavier. There's a little more overhead here. But of course, as we said, the isolation is beyond the namespaces. So it could result in multiple EKS clusters, each of them having their own auto-scaling groups. Definitely in this situation, the whole control plane probably running its own cluster as well. This is, again, a legit situation to have. The other option is, we mostly talked about, so far, the silo approach. The other option is for running a SaaS. I think it's in a more modern applications, is the pooled model. The pooled model basically is meaning that the application, that multi-tenant application, all the customers are using the same application services, the all application servers, and none of them has their own dedicated containers, as an example. And the identifier in between the tenants is a tenant ID in the database, in the context of the request. But eventually, all the customers are using the same application. And the whole isolation happens at the from an application point of view, at the API, at the session level. I think this is the most cost effective. It's harder to do for more legacy applications. I think it's more typical situation for new applications when they are built. And definitely this provides the best cost optimization approach. But again, said it's not always feasible when you talk about the existing environments that you want to deploy. So I do want to show an example of a flow here of how is the authentication happening when you run a multi-tenant, and how do we make it that every customer really feels that is their own environment. And the flow again I'm showing here is something presented available, you'll see in a couple of minutes, as a quick start that AWS built and is available on GitHub for everyone. And whatever you see here is available for immediate download and deployment within your account. So the flow is there is a sample application. So the user then call the tenant with identification of in the domain based on the routing we saw before. The user will reach the web API for that tenant. This API, this web page, will identify the tenant, the user, will identify what pool to use. And I mean what pool is mostly a Cognito user pool and application ID. Then based on once it identified the pool, it will send the authentication information into the pool. Okay. It will start the whole authentication flow. Again, this is, you see this library available in the quick start. It will send a request into the Cognito pool. The Cognito will send back the authorization, and the application will retrieve the JWT token, and then it is passed into the product, and we should be authenticated against the application. This is a very clean way to kind of provide the authentication based on a Cognito capability, and this solution is offered as part of the quick start. I think, from what we see, is a very good starting point when you start building your environment. I don't think it's going to be your production-ready solution, but it's a very, very good start in order to start building your SaaS experience. So we've seen how we authenticate. Now I do want to touch on, again, routing to the tenants in between the namespaces. So we said, the users are going to go based on domains. They will either, from Route 3 directly to the ingress, or probably some load balancers in between. It could be even CloudFront. But eventually the routing mechanism could be the Nginx ingress controller, or the load balancer controller comes with the EKS, which will eventually route the request into the tenant and even down into the service, because you could do a first routing decision based on domain, then based on the URI, and then how we start off distributing the traffic into the tenant. Key element into creating multi-tenant on the same EKS cluster is always raising the topic around the isolation. Customers are always worried about potentially malicious resource that could access another tenant resources, and we will show you how it's doable, and also the quick start also have the configuration how to isolate between. But this is a typical situation we are seeing with customers, and the way we suggest to do that is first is use separate namespaces per tenant. It helps us with, as I said, the resource capacity, definitely creating the isolation. So one tenant resources are attached to a specific IAM policy, and they cannot use each other's policies to access additional resources, but also the network part. And I want to emphasize how we leverage the separate IAM policy. Let's say when you have separate product tables or order IDs per tenant, based on these IAM policies, and let's assume this is a DynamoDB table, we could create a policy that will allow a specific tenant to reach a specific table in Dynamo. And this way, one tenant won't be able to access the other tenant data. However, very often there are shared resources in these cases. Let's say we do want to provide some shared mechanism, and based on putting in the tenant ID or the tenant key into the table, we also can create an IAM policy that will allow two separate tenants to access the same table. However, they will still not be able to access each other's data because of the prefixing of the data, and this in combination with the IAM policy is providing the strong isolation based on the access policy into the table, so one tenant won't be able to access other tenant information. The other point is we very often want to make sure that there is no way to kind of bypass the cross-tenant access. I think it's becoming more and more, a hot topic, and ways to achieve it. For example, Calico putting additional network policies in between the namespaces. There is a lot of discussion about the cross tenants access with container policies. So again, namespace is one, network policies is two. There are more additional services, third parties that are offered. The quick start comes with namespaces and Calico. So as said, we're suggesting to have, separate namespaces per tenant. This is, as I said, a very typical situation. And by being able to provide separate namespaces, we can define separate, quotas, separate capabilities per tenant. It could be very good for tiering. It could be very good for to limit the size of a potential cluster. So whatever you sold to the customer, you always want to live within limits. You don't want to live in an potentially infinite scale, and you always want to monitor these limits. So by having this tenant separate namespaces, allowing us to encapsulate what size the tenant could grow per tenant, and this will definitely, as an example, will ensure that whatever capacity we allocate for the cluster, the maximum scaling is sufficient to allocate the tenants on it. Everything which you've seen so far is part of the quick start that is provided by SaaS Factory. It is available on GitHub. I think it's nice to use it to kind of deploy it. It provides both the UI, the Cognito parts. It's a very nicely built solution. I think as an experimenting, as trying to understand the SaaS concept, I see it very useful, and I think I should try to use it. I do want to jump into now an architecture that is built from a serverless. And so we talk about a more classic way of VPC is accounts, potentially EC2 based. Now we've seen EKS, and now let's go really serverless and how this is helping you to build the SaaS. I would first believe that this is in more modern applications, probably recently built. because, as we know, I mean, serverless wasn't there so far before. The nice part is there's a complete auto scaling, that provide, the agility is very, very cost optimized in that sense. It's easier to operate, the blast radius is limited because these serverless capabilities are really isolated from each other. And as you as a developer mostly focus on creating your application and less on the infrastructure, much less to deal with. And is probably relevant to recently built applications. In a high-level architecture, how would a SaaS based on serverless look like? You have your web applications, probably a React or an Angular application as a user interface, an API gateway that serves the functionality, whatever application services, and built from different serverless. Each microservice have its own compute, application, and databases. That's a very clean approach to that. So again, going back to the quick start, you can see what you will see is a Cognito, a whole environment that is provisioning from the admin console, this SaaS operation console, will deploy shared services in order to orchestrate the application. So when we talk about the silo and pool, there are different approaches of achieving it still in a microservice. It could be talking about the silo approach, that each tenant gets their own set of microservices deployed separately. There are a lot of the same function deployed in the environment, each of them having a separate execution roles. It's still a silo because you do duplicate the microservices across tenants, and you could do the pull mode, which is eventually all the tenants running on the same applications, sharing everything. And again, I think it's easy to understand that adding a tenant to the pull mode is probably having just another couple of more lines in database. Very lean and easy and quick provisioning, while the silo approach takes more at the provisioning time, requires more resources per tenant. Again, it's a very good representation how you could, based on your application needs, have your tenant model in this SaaS environment. So just to recap, I mean, the biggest, what should drive the decision, I think, is your business model, your tiering model, how you distinguish between domains. All of them are right. You should make the decision based on your needs, and just be aware that all the options are available. A very clean way into having this in the serverless domain, in the serverless approach, is to start using Lambda layers, which eventually, software libraries that help you to hide the complexity of the multi-tenancy from the developer. So as we use these layers, for example, we as a user make a request into the environment, into the application. It is hitting the right service, whether it's whatever service it is. And I think what's nice that, of course, and the tenant ID is embedded inside the JWT token. And when we provide the Lambda layers for logging, for metering, for vending of temporary credentials, when these layers are built and they are requiring the tenant context into the request, by building these libraries for your developers, eventually hide the complexity of the multi-tenancy from the developer, which I think is a key product for us as working to develop the SaaS capability into developer to make their development lifecycle easy and hide this complexity from them. So by providing these layers, we can simply call the log function, and again, it will inherit the tenant ID from the token from the session to write into CloudWatch, logs, metrics, and go into STS and vend temporary credentials. So the other approach is, again, another implementation is the tiered access with a separate usage plans. And usage plans are a functionality provided by API Gateway. Imagine that we do want to provide or let customer tenant A to have 100 requests per second and tenant B 200 requests per second. Or we do want to limit the request per second per tenant. So usage plans are functionality comes with API Gateway because this is how we can create the limits, right? Eventually, if there are lambdas behind, we don't want to reach a situation that we are reaching the lambda limits. If it's a silo model or it's a full model, we want to be able to control the resources, the consumption, and because we also want to control the associated cost of running the application. So using API Gateway together with usage plans is a very clean way to achieve it. What it requires basically that every tenant has their own API key, okay? And in this case, we have tenant one, which is the basic tier, having whatever capacity allowed, and tenant two has a separate API key, and it has a different usage plan. So the user make a request into the API Gateway, providing the API key. It goes to the Lambda authorizer, which then gets kind of the policy of what this user is allowed to do. So first, we limited the capacity, the concurrency that the user can make, but also based on the authorizer, we can return back into the API Gateway from the authorizer an access policy, which is deciding which APIs are accessible for each tenant. So in this way, we achieve a multi-tenancy across a single API experience with different capabilities per customer. Another way to kind of limit the concurrency based on tiering is, let's say we built a silo approach or even a pool approach, okay? And the basic tier will allow the 100 requests per second. Another tier will be 300, and additional will be just very larger scale. So by implementing these capabilities, we'll be able to route across tenants, provide different functionality, and as well as control the possible concurrency in the environments. So in the pool model, as we saw previously, was more of a silo approach. In the pool model, again, we have multiple tenants hitting on the same Lambda. Again, each of them have their own limitation profile. And again, each of them has their own IAM context. They're all in the same context, using different just-in-time provided IAM policies in order to gain access to external services. Could be S3, could be Dynamo. And this is how we achieve the isolation in the pool scenario between tenants, where each of them has, a separate data, and either it's dedicated databases or dedicated storage or even shared. But the idea is to use IAM tokens and temporary STS credentials in order to access these environments. So let's take on a full stack serverless. Again, nice way to do that is today, even with Aurora being serverless. So we have the application hitting on the API gateway, a variety of options of authorizing, providing access policies, then hitting on the microservices and all the way to databases. A very typical possible architecture. Everything which you've seen here is available on again on GitHub, as said. We as a quick start, and you can quickly deploy it and test everything which you've seen. Again, as said, it is a very good starting point that I'm recommending you to try. Let's do a quick recap on the takeaways of what I did. We talk about we talked about different patterns of how SaaS could look like. So I think shared services architecture is common to all patterns and as recommended because you probably build a new SaaS solution. So these shared services could be common, they are shared. I don't think there's any reason to do them dedicated or silo per tenant. I'm also suggesting you to reduce the potential blast radius using cellular approach. So when you build your SaaS, always think of the scaling, and I don't think there's infinite scale, and you don't want to have huge environments. So no matter what model you use, whether it's a silo on the same Kubernetes or a silo in Lambdas or whatever, you should think of what is the biggest size of deployable unit that you want to implement. Could be, let's say 100 tenants living in a cell that they share the same AWS account. And once you pass this number, you probably want to open a new account and have another cell in another account. The main point I'm trying to make to you is think of the blast radius. I think this is one of the most important things when you release a software version. When you hit potentially the Amazon limitation, and a user exhausting the resources. There'll be lots of reasons why you want to reduce the blast radius operationally and usage, and always think in a number of cells combining into a number of tenants combining into a cell, and then start deploying these cell units, which I know are scalable units. Very, very important thing. So the full stack silo still requires, the shared services. We don't, as said, recommend to embed the shared services into the silo, have them as a separate supporting service outside of it. Silos, again, are valid for all types, whether it's EC2 based, whether it's container based or serverless based, still fine. Don't assume it's not possible. Routing and the access is again by the tenant ID, tenant identification, and the authentication. I think EKS, it shows that are very easily mapped into the this environment. It's fairly easy to achieve multi-tenancy with EKS. You saw all the tools, all the capabilities to create the isolation, as we mentioned. And I think that as said, do everything that is best to your business, and just map the requirements into the right model, and align with your business needs. Don't think you do anything wrong. Yeah, I did touch on it in the beginning, with limiting the blast radius. Always remember there are account limits, there are management limitations. Don't assume that you can have infinite number of tenants within a single account. And then you should start break your capacity units into smaller chunks. I think it's a very important thing to remember always. So we so far looked at the architecture patterns. Now let's take a quick look from the other side. It was what are possible migration strategies. So there's a trade-off. Okay, one thing is you want to achieve quick time to market. You have your business is pressing, and it's relatively a lighter weight, the easier and quicker journey to achieve the SaaS. However, you want to do a very modernized, very sexy approach. Yes, it requires more work, and the balance. I think the answer is with your business. Do what's correct to your business, not just what looks really sexy and cool looking. Remember, at the end of the day, it's a business, and we have to achieve the business goals. So the migration is more than a technical. I said it is a product. So you have the deployment, operations, sales, marketing, customer success. There's a lot of activities to do in order to achieve the migration. All these things has to happen. I've seen before that there were different discussions around all these capabilities. Yes, as an architect, I think, yes, you should care, be aware of everything need to happen around your SaaS in order to achieve it, and see what's the ramp up of the business around it. So there are many ways to achieve, I think, the SaaS, but think as a product, you build your control plane, the different supporting services, and inside you have your application software. And we did touch it, so I'll go very quick here. And now let's go into the migration models. A classic way is you have your software very often running on-prem. This is true for legacy software, and you simply bring into the cloud. Is a very kind of relatively lift and shift, and it's a very quick start to do. The other option is starting to do more of a layered, of more of moving capabilities into the environment. And when you do a complete service by service, is you start building your service after service in the cloud in a multi-tenant. But again, this is a much heavier work to do. And the quickest, as I said, is a classic silo. Then layered is doing some hybrid in between, and the longest with most effort is service by service. Let's quickly look at what it means in this kind of silo lift and shift. And I see we are out of time, so I'll try to be quicker. So the silo is yes, we build the shared services, the control plane. We start to deploy tenants by these shared services and add the tenant routing, tenant authentication. I think it's, as I said, is a fairly quick to do. And by providing more of these stacks, we create more tenants into this environment. The architecture could look like web application, API gateway, yes or not, I mean, based on the needs. Application load balancer, routing the traffic as a shared routing model between tenants. This is a very easy way to achieve it. When we talk about the layered migration, it is a very hybrid approach. So we want to have our shared services capabilities to orchestrate the different tenants. We do want to have the multi-tenant web tier. Let's say this is now an application that we built dedicated for this migration in order to support our existing IP or applications. We do have this tenant routing based on load balancers. We do add the user management and authentication on top of it. And here we go of having this kind of layered approach. So we start to introduce the shared multi-tenant tools for user management, for tenant routing, but we're still able to leverage our existing solution, or this software, in this SaaS model. The next phase of it is modernizing even more, is adding of course, the web tier, the application tier, but we could still use different storage per tenant. Again, as a layer by layer, we kind of modernize and simplify it. So the addition of new tenant eventually become just adding a new database and providing this kind of access to the database to this additional tenant. And when we talk about service by service, I think this is normally taking longer because you have to build every service. I mean, a nice way to start from it is, let's say we start from a very lift and shift approach. That's how we start with the tenant routing. Of course, we do want to have our shared services to operate it. Then we start introducing new features, new capabilities in microservices. They could even be, a very in a serverless approach. So there are some dedicated resources, silo mode per tenant, with some shared services. Let's say this is a credit card or a shipping feature. Whatever you want to add, you can add them as microservices shared in between tenants. And these services are called with a tenant ID. And this is a nice way how you start to migrate from relatively, older style of SaaS to a new style. And this could be a way, start with a lift and shift and modernize and iterate on it as you go. So what could the architecture look like? Is there's a web application going through an API gateway, application load balancer, which routes into the different tenant VPCs, right? So far, a very silo, a set of shared services, which is very, pooled model, but the user experience, as you see, is very clean. As a user, I have a single login experience. I have a single API gateway I need to hit. Under the hood, it gets routed to different resources. It's an easy way to do kind of this iterative approach of modernizing or expanding your capabilities on the go. And of course, these additional capabilities can call the different tenants, and this is how you achieve it. If you do microservices from day one, I think it's nice. You build them from the beginning, a complete, multi-tenant. So if you have the luxury, go with this way. Think of, you build the separate, the shared services around it, is the metrics, is the logging, provide from the very beginning the partition data access based on IAM, based on different patterns, based on, KMS keys, into this microservices approach. I do want to kind of a quick recap on the pros and cons of each of them. So in a silo lift and shift, the biggest advantage is the time to market. You have your software, it's probably being used lots of places. You can bring it up to the SaaS very quick. You have to train your business, you have to start quickly. Probably is a very good way to go. And the isolation is much, much easier. From account to VPC to subnet to knuckles, easy way. However, the cons of it is less agile, is more infrastructure to deploy, is more costly, is harder to manage. And again, here's your trade-off to do, and it could change over time. One solution could be right at specific time, another way could be later on. So you can start with a lift and shift and potentially, even consider layered at the time. Layered, yes, is very incremental. You can start silo and start shifting some of the resources to be more multi-tenant. You can start showing quick success. Let's say you have, a silo model and you want to add a new feature, a new capability to your SaaS. Having it as a layered approach could show quick success. Again, it's more timely from a lift and shift. It's still complex to manage. Remember, there are resources for the tenant, some shared, could be more, is harder to maintain. And cost-wise, because of its, still relatively silo in that approach, could be more costly. And the service by service, I think, again, it's very incremental. It does provide you a really fully modernization at the end. It's really, an agile and scalable. But again, you have to pay in more time, in more resources to achieve it. Moving from data model in the silo is much harder into service by service, and it's much more complex in that sense. So a classic path that we see, phased approach. Yes.
Hey, I think so. We're a bit over. How many more minutes do you think you would need?
2 minutes. I should be done.
Thanks.
So the phase approach is start as lift and shift, start adding some shared resources into the layers, and then going to service by service, start porting them to be a really nicely multi-tenant. But you can also branch to service by service from the silo. So again, all these are valid, and you have to think what's right for your business. A parallel migration is basically building a monolith, stacking next to it, new features in microservices, adding, the multi-tenant web tier, and all those combinations are really nice. And then you can start move your users from one style of deployment into another style of deployment. These are really, really common things that we see. How to start with multi-tenancy? Think of the onboarding capability. Think of the tenant resources, authentication component. Be aware always of the tenant context in the environment. I want to jump to the takeaways and then finish. Never assume things are quick, and do not assume you have lots of time, because I'm sure there's pressure from the business, and they want to start showing the first version of SaaS. So don't assume you have all the time, and you have to start showing results quickly. Focus on the SaaS building blocks, on the control plane, on these capabilities of onboarding identity. Think of it as a product from the very beginning. Support a multi-tenant from day one. Don't assume you just start with one and then you see what to do. Think of these multi-tenant capabilities from the beginning, isolation, concurrency. Think of these from the beginning. Instrument the metrics to have the right visibility and understanding what's happening within each one of them. Present these metrics to your business, to your stakeholders, so they can make the right next decisions based on these data. Think of the tenant aware, whether it's the monitoring you wants to see all the tenants as, and just those who are higher utilization, but you still want to be able to dive deep into a specific tenant. So the tenant aware management and monitoring is really, really important from day one. Just try all those moving parts with each iteration, and continuously, be aware and focus on what do you need, and if this solution is meeting your business needs. Sorry, it took me a little longer. You are very welcome to talk to us and share your challenges and needs with us. and together we could find the right architecture or migration path for you, and helping you to achieve your SaaS. There are so many ways. All of them are right, and it's your business who have to decide what's right for you. Thank you for listening.